Now I'll focus on one class of symmetries that happens when you have scalar fields defined in position and time. Again, another clash of notations, and I can change this one. This will make sense. So here X is configuration space coordinate. I have a domain from 0 to L, and I have a U of that 0 to L is my domain. That's what I call X, and I have a scalar field over that domain that changes with time. It can be turbulent. That's something interesting. We usually do for problems like this, we say, okay, let's assume periodic boundary conditions. Then once you have those, you can make a Fourier expansion. So, and then you put all the spatial dimensions, the Fourier modes. You have infinitely many of them. Then you can solve the problem in terms of amplitudes of Fourier modes and truncate them at some point, and then you will have a state space. So let us work in this state space. Where our coordinates are real and imaginary part of Fourier mode amplitudes. And I also assumed that this field is real valued, so I can only take positive Fourier modes. Assume that the laws that determines the evolution of this field does not depend on translations in X. So something happens here, something happens there, same law of motion, same Newton's law, same something that is independent of shifts in shape, and also our boundary conditions are also telling that if you move forward, same boundary condition, it just has to be the same thing at L shifted location. So then this will be a translation symmetry, and the translation symmetry will look like a rotation in the Fourier modes. If I make a transformation like this, then this transformation, by the definition here, becomes multiplication by a complex phase for Fourier modes. And that phase is simply, if I shift by delta x, I basically put a phase delta x scaled by the coefficients, and each mode, for each mode, that phase is multiplied by the number of mode. So first mode is multiplied by theta, second mode is multiplied by e to the I2 theta, and so on. Then, for the state space I define, I can write the group action as big matrix of rotations like this, cosine theta minus sine theta. The block diagonal matrix. And zero everywhere else. And then the corresponding group generator will look like Again, block diagonal, both of them.